we'll do it. We'll put a code word later on in the video. Think about what you want the code word to be. Rectangular to polar, and polar to rectangular. Suppose we want to go from r theta to xy. Or suppose you want to go from xy to r theta. What I'm going to do is I'm going to plot a coordinate. That coordinate could be either r theta or xy. And like we do with everything in trigonometry, we're going to draw a triangle formed by that coordinate and the x-axis. And now I'm going to label 4 parts of the triangle. Anybody want to guess what I call this?
A.
We're going to call it x. How about this?
Y.
Y.
R.
R. Theta. Those 4 elements are theta and x and y all up there in my picture, aren't they? We want to show a relationship that relates those together. For example, can somebody think of a way in which x, y, and r are related? X, y, and r.
It's kind of like a squared plus b squared.
It's exactly like a squared plus b squared c squared. So you got r squared is equal to x squared plus y squared. Pythagorean theorem comes into play. So therefore, if you want to find out what r is, okay, you would say r is equal to the square root of x squared plus y squared. And that should look very familiar because that's something we did pretty recently. Finally, I want to now use x and y and theta. What's something that relates x, y, and theta? Something that relates x, y, and theta. Close?
Or no, sorry, tangent.
Tangent. Namely that the tangent of theta is equal to y divided by x. So you again get to make your own notes for this next test. I do not allow you to put examples on there, but if you'd like to put these formulas, those would be good things to put on your test. Everybody got that? Okay. All right, so now we want to convert to polar rectangular. So instead of like figuring out r and theta, we want to figure out x and y. So I have x equals and I have y equals. So suppose I was given r and theta, and I wanted to find x. What relates r, x, and theta together? Cosine of theta is equal to the x value divided by the r value. If we multiply both sides by r, notice that we get x is r times the cosine of theta. We've seen that before. That is the horizontal component of a vector. So again, all this is stuff we've seen before. And then finally we have y. Suppose we have r, y, and theta. R, y, and theta. That would be the sine value. The sine of theta is equal to the y value divided by r. So if you want to solve for y, you multiply both sides by r. And those are your 4 pieces. So today we're just going to make use of those with these examples, and we'll be done. The first problem says convert 4 2 pi over 3 to rectangular form. So this is currently r theta, and we want to convert it to x and y. And in order to do that, we know that x is equal to r, which is 4, times the cosine of theta, or 2 pi over 3. And the y value will be equal to 4 times the sine of 2 pi over 3. So what I do with this is I need to come up with the terminal point for 2 pi over 3. Does anybody remember what the angle is for 2 pi over 3? How many degrees is that? 120. So at a 120 degree angle, do you know what this location is, that terminal point? What is the xy value there? Negative 1/2.
Positive root of 3.
Yep, positive root of 3 over 2. So as I work to simplify those, I use negative 1/2 for cosine because cosine is the x value. So 4 times negative 1/2. And then the y value would be 4 times the root of 3 over 2. Notice that 4 times negative 1/2 is negative 2. And 4 times the root of 3 over 2 is 2 roots of 3. This is the rectangular coordinate of that. Okay. And so one way to kind of check your work, if you were to plot this, you would rotate 2 pi over 3, and then you would go 4 units in that direction, okay? And you would place you right there. Does that look like about what it would be if you were to go back 2 and up 2 roots of 3? And sure enough, it looks like we place it in the same spot. I'd like you guys to try this one on your own. See if you can turn that into rectangular form, follow very similar to what we just did, and you should be just fine. Thank you. I'm glad you didn't rip your pass.
I'm glad you didn't rip my passes. Whatever.
Hopefully you guys found that the terminal point for 5 pi over 4 is negative root of 2 over 2, negative root of 2 over 2. Okay? And so if you multiply negative 2, see the negatives cancel, and the 2's will cancel, so you get root of 2, root of 2. And again, I noticed that the root of 2, that's in which quadrant? First quadrant. So does that make sense? It looks like if I rotate 5 pi over 4, it brings me here, and then go negative 2, that means I move in the opposite direction, right? So that does make sense then. Okay. All right. Okay. Find the polar coordinates for this. So now you want to take this and turn it into r theta. Find the polar coordinates. We know r is equal to the square root of, we do x squared plus y squared. If you square the x value, you get 9. If you square the y value, you get 9. So we get the square root of 18, otherwise known as 3 roots of dos, which is Spanish for 2. And then we use tangent of theta is equal to what? Tangent of theta is equal to y over x, which gives us negative 1. Where is tangent negative? Which quadrants is tangent negative?
The second and the fourth.
Second and the fourth. Is this the second or the fourth quadrant?
This is the fourth.
Fourth quadrant, so you're over and down. So we're looking at fourth quadrant here. And if you would inverse 1 on your calculator, you get 45 degrees. And that means that if you were to rotate all the way around there, that would be 315 degrees. We would like to convert that into radians. Do you remember what 315 is in radians?
7 pi over 4.
Very good, Brian. 7 pi over 4.
Wait, how did you get that, like 45 degrees?
So if you, on your calculator, do tangent inverse of 1,
Oh.
you get 45. go ahead and do the next one on your own. This one does get a little bit trickier. A couple mistakes made here on this next one by people. I've got 10 for the radius. Anybody have a question how I came up with 10 for the radius? A lot of times people leave this, they say, well, my angle is -1 over the root of 3. That is not an angle. That's what tangent is equal to. Notice that tangent is negative. Tangent is negative in the second quadrant and the fourth. This places me in the second quadrant. If you inverse 1 over the root of 3 on the calculator, anybody confident what they got? 30 is correct. That means that this is 150 degrees, which if you convert it to radians, that would be 5 pi over 6. So 10, 5 pi over 6 is your answer. If the problem looks familiar, it's almost identical to the problem you had on your test 2 tests ago, which I'm sure you don't fully remember. But yeah. You good? Okay. All right. Now what we'd like to do is we would like to finish this off by writing these equations and putting them into what we call polar form. This first one is a line, and if you were to solve for y, which you don't need to, but if you were to solve for y, you get y is equal to 1/2 x. And everybody knows what that shape looks like. It's just a line with a slope of 1/2, right? So it would just look like that. So whatever I come up with for an equation for this in polar form, I want it to look like that as well. And what we're going to do is we're going to substitute for x, we're going to substitute r cosine of theta. And for y, we will substitute r sine of theta. And thus we get r cosine of theta is equal to 2r sine of theta. And in the end, we either want to solve for r equals or we want to solve for theta equals. So what do these share on both sides? They do have a theta. One is taken up by the sine, the other is taken up by the cosine, but they also both have a r. Notice if I divide both sides by r, the r completely divides off. I'm left with cosine of theta is equal to 2 sine of theta. So that tells me that this is not solving for r equals, this is going to be solving for theta equals because the r is completely gone. You see that? There's no more r. So if I'm solving for theta, this becomes a trig equation, which we've dealt with before. I'm going to combine these together by dividing both sides by cosine. So instead of having a sine and a cosine, what do I have instead? Tangent. So now we have 1 is equal to 2 tangent of theta. All we want to do is solve for theta. So we divide both sides by 2. I get 1/2 is equal to the tangent of theta. Just as Bryant is doing, we go to our calculator and we do tangent inverse of 1/2, and you get 26 degrees. So think about what we said first. 26 degrees is about like that, isn't it? Is that what about the line y equals 1/2 x looks like? Yeah, so theta is 26 degrees, that works. Except we're not supposed to be in degrees for our answers. What are we supposed to be in?
That's what I was just gonna ask.
Radians. So we can multiply this by pi, and we can divide by 180 to convert it to our radian, and we get 0.46. So our answer here is theta is equal to 0.46 radians. Okay, and if you need to think about that again, that was about 27 degrees, I think we said. Okay.
Can we just do it in radians in the first place?
You could do it with radians in the first place, yep. So take out your calculator so you can understand these next pieces. What's interesting is if you press y equals, I'm going to show you guys a new mode. If you go down to mode, first of all, make sure that you are working in radians. And then if you move down, we're going to move out of function mode. So function mode uses x and y, rectangular coordinates. You're going to move on over to polar coordinates and press enter. And now when you press y equals, you don't get a y equals, you get r equals. We can graph things in polar form that we couldn't graph in rectangular form. We're going to do 2 of those examples right now. This says x squared plus y squared is 25. What shape does that make if we graph it?
Ellipse.
So the C rhymes with Urkel.
A circle.
Make a circle with a radius of 5. Okay, circle with a radius of 5. We're going to show you that we're going to plug in r cosine of theta for x, and we're going to plug in r sine of theta for y. And so when we square, we get r squared times the cosine squared of theta plus r squared sine squared of theta is equal to 25. I don't know about you, but that looks kind of bulky, doesn't it? But there's a little trick here. What can I factor out of both those terms? And I get cosine squared plus sine squared. Sine squared plus cosine squared is 1, isn't it?
Yeah.
So this just disappears, doesn't it? It becomes 1. 1 times r squared is r squared. My goal is to solve for r. If r squared is 25, what is r? 5. So no matter what theta is, the radius is always 5, which should make sense that it would be a circle. So if you go to your calculator here, I want you to just type in 5. And then I'd like you to type in zoom standard. Choose number 6. And is the graph a circle?
Mm-hmm.
It is, but it looks more like an ellipse because your calculator is elongated one direction, isn't it? So if we zoom as a square, it forces your calculator into, a dimension that would produce a circle. Could you graph a circle before? You couldn't because it doesn't pass a vertical line test. In rectangular coordinates, a circle is not a function. In polar coordinates, it is. You can actually graph all sorts of cool things, and you can play around as much as you want. Here's one for you that I kind of think is interesting. I'm going to do 9 times the cosine of, we'll do 5 theta. And the theta value is right here. It's your xt. As I press graph, you're like a flower. It turns out that any shape that exists in the universe can be mapped into an equation mathematically, whether that be rectangular, whether it be polar, whether it be parametric. Anybody Batman fans here? Love The Dark Knight. Great movie. And I had a student one time, he came up with a formula, I looked at it online, for making the perfect Batman symbol. He spent about an hour and a half in class over 2 days, and he typed it in, he pressed graph, and he was able to come up with the Batman symbol graph in his calculator. Which is pretty cool. I liked that. But there's all sorts of crazy shapes that you can make with your calculator. Which would seem to be a good time to interject our word of the day. What should be our word of the day for our people watching the video?
Batman.
Batman. Batman. There it is. Who do we think gets it first? I mean, Vea is a good choice, but Max is on top of things too.
Vea's not gonna get it this time.
Okay, all right.
Going into a weekend too.
Yeah, because they got all weekend to do it.
Yeah. All right, we got the next one. Last one, x equals -2. This graph makes a vertical line. All I'm going to do is I'm going to plug in r cosine of theta for x. And we either want to solve for r or we want to solve for theta. In this situation, it's going to be very easy to just solve for r. So I will simply just divide both sides by cosine. You get r is equal to -2 divided by the cosine of theta. You can leave your answer like that, or you maybe remember that 1 over cosine is the same as secant. So either one of these will work as an answer. But once again, it's a vertical line, which is something we could not graph before. If we go to our calculator now and you type in y equals, and you type in -2 divided by the cosine of theta, sure enough, it will produce a vertical line for you. And so that's that. You're ready to complete this piece. Homework should follow very similar to what your first stuff did. It should be good to go. I'm going to press stop and I'm going to post this online so people have it right away.